Okay. We are going to continue our discussion on functions. But today, we are going to talk about these 4 vocabulary words. Okay. So, the domain of a function. Are all the x values, aka the inputs. Brooks, what do you think the range is going to be? Yes. Which would be considered our outputs. Okay. So today we're going to practice taking some sort of relation and describing what is the domain, what are our inputs, what is the range, what are our outputs, our x's and our y's. Once again, we are in alphabetical order. Domain, range, x, y, input, output. Connor, did you hear that? It's, what did I say? So you didn't hear me? We're always in alphabetical order. X, comma, y. Input, output. Domain, range. Always alphabetical order.
That's a good way to think about it.
This is getting a little bit confusing. Is this
Just don't think about
gonna
it.
like stay? Is it gonna stay like?
Just don't think about it.
Instead of X?
Okay. Now, our independent variable is basically our inputs. Okay. Our dependent variable depends on the independent variable. So this is our output. Okay. It depends on the inputs to get the outputs, right? If I have an equation, y equals 3x plus 7, and I say plug in x is 3, plug in x is 4, plug in x is 65, okay? I can't get a y unless I plug in an x. You see what I'm saying? Yeah. So y depends on x. You don't have a grill. Stop licking your teeth. You're being creepy. Okay. What? Okay. I'm gonna give you a piece of paper that I want you to fold like a book.
Vertical. It's this way. Or have this way. Yeah. Kyrie, how's your pinky toe? Kyrie, how's the toe? I can see a blood.
Oh no, we didn't say just like any. No, it's not.
Yeah.
Actually,
One.
Four.
Did I fold it right this one?
Yeah.
Wow. Wait, but what side do we fold on?
Yeah. Take a guess.
One side.
This is the front side, right? Oops. Right here. Front side.
And I get it wrong. All right.
My brain is full of.
That wasn't to get your attention, that was like a real. Was it? I had.
It sounded pretty logical. I thought you were
Did you ask her?
Yeah, I had this like way before everyone else.
See, this is why
So,
this home is
so
so
classy.
Trend setter. Yeah, I really just needed it because of the handle, then I can carry it with me.
You want the other one. Yeah, you should get the one by.
Hey, Tillman.
Oh, that's the one.
Cause I grew up in Kansas.
You guys know like the refs, like.
Hey, a win's a win.
All right. I need you to look up here. Stop being a salty loser.
Yeah.
Yeah, no, it is a pretty cool.
Valerie, how many ordered pairs do you see up here?
Five.
They're on your
Six.
paper too. Is your name Ellery?
James will check it out. Not me.
How many, Ellery? It's on the piece of paper I handed you.
Wrong page.
It's one. Right there.
Okay. Connor, how many ordered pairs are in this picture?
Oh, I was so mad because it's one. He's learning.
I think there's one right here, and I think there's one right here, and I think there's one right here, and I think there's one right here.
It's like when it.
Each time it touches a line. Wait.
Every time it hits.
So
So,
like-
yeah.
I can't. count.
Oh, infinite.
Can we just do the symbol or do we have to spell it out?
You can do the symbol.
Yeah.
So you see one dot.
Is it 50?
No. Anywhere you see curve, there's a coordinate. Okay, there are an infinite number of ordered pairs. So this is the difference between what we call a discrete and continuous relation. A discrete relation contains a finite number of ordered pairs. We can literally count them. Here's a dot, here's a dot, here's a dot, here's a dot. Where a continuous relation is going to contain an infinite number of ordered pairs. And we're actually going to be able to like draw, like trace it. Okay. Okay. So I want you to just kind of like look with me here. These right here, these are discrete because we just have, here are some ordered pairs. Okay. Whereas like when we go to like over here, these are continuous because we can trace them and they have an infinite number of coordinates. Do you see what I'm saying there? Yeah.
And how do we find the common, the domain and the range of those?
Guess what? I'm going to teach you.
Yeah, we're getting to it.
Yeah.
Okay, so let's just start with the discrete ones. Okay, Henry? Let's start with discrete, Brooks, and then we'll go from there. So what did I say about the domain? That is all of our inputs. So in this relation, I am going to look at all of our inputs. So I'm going to write that our domain is the set of -2, -1, 9, and 10. I like to put them in order. That's all I did. Okay. Now our range is this the set of our outputs. Okay, what are our outputs? Okay, so we are not going to have to write 1 twice. We can just write 1, 5, and 6. If you do, I'm not going to be upset, but it's not necessary.
The line.
So the braces are just saying like, hey, this is the group of numbers.
I can't really like draw those. Same here. I'm gonna use just parentheses.
It will be fine if you just write the numbers.
I don't like how.
I am sorry. Noah, is this a function? Okay. Noah says it's a function. Kyron, why is it a function?
Because all the outputs have one input. Or no, it's the other way around. All the inputs have one output.
Okay, all of my inputs have one output. All of my X's have one Y. Okay, great. Okay, so here in number 2, we are just writing down our domain are the inputs, our range are the outputs. Okay, so domain, I'm gonna look at my X's. What numbers do you see in the X? 3, 4, and 5. Cool. The Y's are going to tell us what the range is. What numbers do we see? I see -3, -1, 0, 2, and 4. Brooks, do you have a question?
No, I was gonna give you the answers.
What's the function? Or is it a function?
No.
Brooke says no. Drew, do you agree?
Wow.
Why do you agree? Give me an example of Brooks, put your hand down. Kyron, put your hand down. Drew is gonna answer this no matter how hard you try. Okay. What is the problem? Like, point to me the problem. Like, point to me how you knew it wasn't a function. Like, okay, so the input of 3 has 2 outputs. The input of 4 has 2 outputs. Now you notice, hey, I have 2 of the same X's, 2 of the same X's. That's what flagged you, okay? We would describe that as, I have this input with 2 outputs. I have this input with 2 outputs, okay? Yes.
Questions on a test where they.
Now, that is a good question. I don't think I would ever give that to you, but could we determine if this was a function based on this? Yeah, we could. Because I don't have enough domains to have unique ranges. That's an excellent question. Like, I have more Y's than X's, so I know this isn't going to be a function because I'm going to have to map more than one X to a.
So if it shows up like that, you can do like alternate version of this. You can just say no since we see there's no Y. Yes.
He was just giving a hypothetical. How about you guys answer 3 and 4 by yourself?
I can do was the order them like from least to greatest or page.
That's going to be easier for me when I grade your work. Answer me 3 and 4. They should have pulled them.
No, they should.
Oh, dude.
None of your business.
Hey, I'll see the brass one. 1 and 6.
I don't like the
Not bad.
Okay. Here we go. Jacob, what's our domain for number 3? Okay. Kaylee, what about our range? Henry, is it a function? Okay, why is it? And number 4, Noah, what's our domain?
4 and 8.
Okay, Izzy, our range? Okay, DJ, is it a function? Ethan, why is it not a function?
It's too many outputs.
Okay, our input of 4 has more than one output. That was pretty quick. All right. Okay, here we go. Now let's go. What happens when we have a graph? Okay. When we have a graph, I want you to scan from left to right to collect all of the X values. Then I would like you to scan from bottom to top to collect all of the Y values. Connor? So, okay. So let's do this. What is this coordinate right here, Connor? Okay. This guy would be -1, -3. This guy is 2, 0. This guy is 2, 2. And this guy is 4, 3. Okay. So when we go from left to right, I see that we have X's of -4, -1, 2, and 4. Do you see what I'm saying there? As we go from left to right, I can pick out all of those X values. Now, if we go from bottom to top, I can pick out all of the Y values. It looks like we have Y values of -3, 0, 1, 2, and 3. I go from bottom to top, boom, 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 all of the Y values. Okay. All right. Caden, is this a function? He was pretty emphatic about that. Okay. Ian, why is it not a function?
Too little domains for too much range.
Okay, this does not pass the vertical line test. At x equals 2, we hit 2 coordinates. I know, you're like ready for some supper? Ready for a little afternoon snack? Okay. I would like you to please answer 6 and 7 for me. I also want to say how disappointed I am by the number of gold sheets that got left behind yesterday. 7 of you left your gold sheet yesterday. I make those for a very important reason.
I had mine.
Thank you, Harry.
I need my mic.
They're in my extra drawer. You can get one later.
I'm sorry, I should just.
He's not smart.
It probably should. Sometimes, yeah. I've missed so much. Next time I get a good shoot, I would expect to walk it. Probably my federal form sign.
We're just not even gonna use it.
I know. I was, yeah, what? Yeah, no, my board sheet disappeared.
All right, here we go.
Well, I'm not done.
Start talking.
We're supposed to do both this.
Yeah. Zayden, what did you write for your domain in number 6?
-2, 0, 1.
I love it. Those are the x coordinates of all of those dots. Okay, Harry, the range.
-2, 1.
Excellent. Reese, would you say that this is a function? Reese said that yes, this is a function. Ella, why? If passes the vertical line test. Not bacon, lettuce, tomato, but the vertical line test. I'm more of just the BL. I don't really want the tomato. Yeah.
What's all the-
Yeah.
Okay, Gabe, what's our domain?
-4, 0, 2, 3.
Awesome. Hold up.
Wow.
He was trying to copy the
I
answer.
was checking
Okay.
the answer.
Allison, range? Did you say 3 and 4? Okay, sorry. Well, she said 3, but she forgot the negative. I fixed it for her. It's fine. Okay, Ethan, function? No, Eli, why not? It does not pass the vertical line test. Awesome. Okay, now, Henry, so that you do not panic, we are going to talk about continuous ones. Yeah. So sort of kind of. Okay. So when we have a discrete relation, we can pick out, here are the numbers and we can list them for domain. Here are the numbers and we can list them for the range. But we're not going to be able to do that for a continuous function or continuous relation, I should say. So here's what we're going to do. If I go from left to right, notice, do I have any graph right here? Do I have any graph right here? I start at x equals 1 and it keeps going to the right forever. Do you see that?
No.
So we could write x is greater than or equal to 1 because we start at 1 and it goes to the right. Okay. Now, I'm going to put my pencil horizontal and I'm going to go from bottom to top. Do I have y values? Do I have y values? Do I have y values? Are they going to continue?
Yeah.
This arrow means I'm going to keep going forever. So we have y values for all real numbers. It's like an R with 2 backs.
I'm just gonna write all real.
Okay.
Oh, no, the menu.
All real numbers. This is a number sign. All real numbers.
We're going half on that. It's like a TR.
It's like a double backed R. Yeah, like the paragraph P, but it's an R.
This Harry did.
Oh, sheesh. Okay. Is this a function? No, it fails the vertical line test. All right, we're gonna get really good at this. Are you ready? Okay. In number one, first of all, let's just talk about, does this pass the vertical line test? Yes, it's a
Let's
function.
go.
Okay. Now, take your pencil, hold it vertically. We're gonna go from left to right. Do I have X's?
Nope.
Do I have X's?
Nope.
Do I have X's?
Nope.
Oh my goodness, I have X's everywhere. So our domain is all real numbers.
Yeah, wouldn't the range be?
I have no idea what I'm doing.
Would it?
Well, all this stuff.
I thought.
Anything below,
Okay, so notice how we have blank space right here. So our first Y value is here at -3, and they get bigger. So Y is greater than or equal to -3.
So I have a question. So you got domain for number one is x is greater than -1, but on this one we got all the numbers. How does that possible?
Because from left to right, I have X's everywhere. But here, from left to right, I have blank space right here. I don't have any X's here. Okay. Okay. What? Okay, now let's look at number two. First of all, is number two a function? Yeah, it passes the vertical line test. Okay, so domain, we go from left to right. Do I have any X's? Right here?
No.
No, not until -2. And then as we keep going,
it gets greater.
they keep going. So we start at -2 and get bigger.
Looks how it's flip flop.
Give me a moment and I'll show you. Okay. So bottom to top, do I have Y values? Do I have Y values?
Yeah. Yeah.
Do I have Y values?
No.
This Y value is
3.
3, and they're all below it
So y is less than.
or equal to 3. Yeah.
What about the first one, because there's empty space right here, and then there's not always Y values.
Well, so the Y values are going to keep building up and keep going down because of that arrow. Okay. All right, now in number 3, this is not a function because it doesn't pass the vertical line test. Our domain, if we go from left to right, we have empty space over here. This is X is 2, so yeah, X is less than or equal to 2. That's how we would write that, Mr. Kyron Sporsic.
Alright.
Okay. Now, do you see these arrows? This thing is going to keep going and going and going and going and going. So I know we don't see all the Y values, but they're going to be there, right? If we go from bottom to top, there's not going to be empty spaces. Okay. Okay. Now, before the bell rings, we are going to talk about this one right here. Do you see how this is an open circle?
It's means that it's just going to be great.
So this is just X is greater than X is greater than -2.
Why did we have to do that last time? That really gets me. Oh my god.
Can we do a range?
Y is greater than or equal to -3 would be that range. Let's put that inside your book. You have a book assignment and we'll do a little practice with this tomorrow, okay? Because I actually have a coordinate here, where here I have a circle. Unless there's an open circle. To start. So the Y is always top to bottom.
Okay.
Yes.